Hi, today you're going to be learning about factoring expressions. This is section 5.5. So I want you to think of factoring as the opposite of distributive property. It's reverse distributive property. And when we distribute a number, we're multiplying, right? We talked about how in PEMDAS, multiplying, you might see the distributive property, which represents multiplying. So if it's reverse distributive property, when we factor, we're going to be dividing. So example 1, factoring numerical expressions. So factor 18 plus 30 using the greatest common factor. So just to go back to what we did earlier in the year during our first chapter, we found the greatest common factor using the upside down cake method, which you are absolutely welcome to do. So I will remind you of how to do that. So we have 18 and 30, and you take out any common factor that they share. So I'm going to say, let's say 3. 18 divided by 3 is 6. 30 divided by 3 is 10. If what you have now can still have a common factor taken out, you continue going. You create a second tier to your upside down cake. 6 and 10 have a common factor of 2. You divide, and we're stuck with 3 and 5. So as a reminder, the GCF is found by circling your numbers on the left side and multiplying them. So my GCF is 6. So when we factor out a number, we are going to basically take 18 plus 30, and we are going to divide each of these by 6. So we're going to take a 6 out, and 18 divided by 6 is 3, and 30 divided by 6 is 5. So we just created a problem that looks like the distributive property because we reversed distributive property. All right, let's look at B. Now this work, you can absolutely show this if it makes you feel more comfortable, but it is not totally necessary if you can figure out the greatest common factor on your own. So I know that the greatest common factor of 20 and 12 is 4. So I am going to divide 4 into each of them. So I took a 4 out. I'm left with 5 minus 3. And that's the end of the problem. We don't solve it. We're just factoring. It look more like a 5. One of the biggest mistakes that I see when students factor is forgetting to put the number out front or forgetting to put the numbers in the parentheses, the sum or the difference in the parentheses. You want to have both for it to be a correct answer. Okay, so example 2. We're going to factor algebraic expressions now. So basically you're taking out whatever common factor they share. So we have 3x and 42. I'm going to show you with the upside down cake method again. It's what I like to use. I know 3 can come out of both of these. Well, 3x divided by x, 3 divided by 3 is 1, so I'm just left with x. And 42 divided by 3 is 14. X and 14, we don't know any common factors between the two of them, so our answer is 3 times x plus 14. Now, a good way to check your work is if you were to distribute these, you could distribute it, and if it looks like your original problem, then you know you are correct. All right, what comes out of 63z and 27y? Well, I know the number 9 can come out of each of them. That leaves me with 7z and 3y. and they have nothing else in common. They don't have any numbers in common, and they don't have any variables in common. So my answer is 9 times 7z minus 3y. Okay, word problem. You receive a discount on each book you buy for your electronic reader. The original price of each book is X dollars. You buy 5 books for a total of 5X minus $15. So if you were to solve that, if you knew what X was, if you knew how much each book costs, you would be able to figure out how much money you spend. Factor the expression. What can you conclude about the discount? Okay, so we've got 5X and 15. I know that 5 comes out of both 5X and 15, and I'm left with an X and a 3. So my factored answer is 5 times X plus 3. So what can we conclude? Let's see. You receive a discount on each book for your electronic reader. Oops, I made a mistake there. This should be minus 3. Discount for your electronic reader. So in the original, this minus 15 is the discount for all of the books. When we distribute out of 5, this minus 3 is telling you what the discount is for each book. So we will have a $3 discount per book. Okay, and then we've got some challenge problems. These are a little bit more difficult, but important still. We do this the same exact way as we would with what we had before. So we could use the upside down cake method, 12xy and 36x. Okay, well, I know that the number 12 goes into both of these. So I'm going to take out 12. That leaves me with xy and 3x. These have a common factor still. Remember, factors are numbers that are being multiplied to make a product. And variables represent numbers. So I see that this has an x factor and this has an x factor. So you can actually take out an x. So xy divided by x leaves me with just y, and 3x divided by x leaves me with just 3. So my answer there, I'm going to have to go down here, is 12x is being pulled out because that's what's on the side, and y plus 3 is what is in the parentheses. That represents the sum. So yes, you can pull out variables as well. All right, let's look at this next one. This one we've got 3 terms. Still works the same exact way. Okay, what number can come out of all 3 of these? 13. That leaves me with x squared, 3xy, and 4x. Okay, do these still have a common factor involved? Do you see something, a number or a variable that they all share? Yes. I am going to divide out an x. They all have an x. So x squared, we know, is x times x. And if I am dividing out 1x, this over a little bit so you can see this. If I have x times x is x squared, and I'm dividing out an x, we can cross out one of the x's in the numerator and the x in the denominator, and we're left with 1x. Okay, 3xy, if we factor out an x, we're left with 3y. And 4x factor out an x, we're left with 4. So our final answer is 13x times x plus 3y minus 4. Please make sure you're checking the operations for your final answer. And if you'd like to check your work, you can distribute to check to make sure it looks like your original answer. 13x times x is 13x squared. 13x times 3y is 39xy. And 13x times 4 is 52x. And there are your notes for section 5.5.